In this video, I want to talk about how to calculate z-values in relation to the normal distribution. So if we were to design a study, go through and collect our data, at that point we might want to do a histogram or a stem plot in order to figure out what type of distribution we have. We might also want to calculate our mean, our standard deviation. And what would happen is that our normal if it turns out to be a normal distribution, which is the bell-shaped curve that we're all familiar with, every data set would have a different value for the mean and the standard deviation, which are these values across the bottom here. So every data set would have a different mean, a different standard deviation, which makes finding the probability that something occurs very difficult, because you would have to hand calculate all of those. Well, to avoid this, what we do is we have the standard normal distribution. And the standard normal distribution is denoted by these values. This normal distribution that's standard always has a mean of 0 and a standard deviation of 1, which makes calculation of different probabilities easier. Now, once we have figured out that we have a standard normal distribution, what we're going to need to do is we're going to need to take a data value, and we're going to need to find out, for example, the probability that that data value would occur. Well, to do that, we have to first convert a data value into a z-value. And here is the formula for doing that. We take the data value that we're interested in, we subtract the mean of our distribution, our calculations that we did for our data set, and we divide that by the standard deviation. Now that's going to give us a z-value or a z-score. Now once we do that, we might want to find the probability that our data value occurred, or that values less than our data value occurred, etc. Well, there are three possibilities. We might want to know the probability or the area to the left of a particular z-value, to the right of a z-value, or the area between two different z-values. And we're going to talk about each one of these at this point. Now, most of the time we're going to use either StatDisk or StatCrunch to find these probabilities. However, it's useful for you to understand how the software is calculating the z-values. And there is actually a table of z-values in the back of your book where you could actually calculate these yourself. Now, case 1 is the area to the left. And the way that the table in our textbook does it is it always shows the area to the left of a z-value. So let's just say this z-value is a 0.9. If I want to know the area to the left, or the probability of z being less than 0.9, all I have to do is look it up in the book, and that would be my z-value. Let's look at the second possibility. And the second possibility is I want to know the probability of a z-value being greater than some number, and let's just use 0.9 again, and that would be the area to the right. Well, the total area under this curve, or the total probability that something will occur, is 1. So all I have to do is look up 0.9 in the back of the book and subtract it from 0.1. Now, our third probability is between two z-values, and what we would do is we would look up z2, which gives us this entire probability, z1, which gives us this entire probability, and subtract the two. And that would give us we would take the value of z1 from the value of z2. Now, when we get to hypothesis testing later in the textbook, you're going to use a p-value, and the p-value is nothing more than the area under the curve, or a probability finding a z-value using one of the three methods that we've just talked about.